Hello, and welcome to Stat 2050 at the University of Wyoming. We are online and having just a great time. Alright, so this is the first video. You can kind of think of it as like a preface to the class. More or less just kind of going over some terminology and just the general idea of what we're doing in this class and what statistics is about in general. So, let's get into it. If you Google statistics, you're just going to get a bunch of hoopla that doesn't really mean anything to us, at least. So the internet says that stats is a form of math used to quantify models and real-life experimental data, studies, whatever. That's not great for us. That's not a very inviting description of statistics. So let me sort of give you what I think statistics is, and sort of what people in our department sort of think statistics is, because it's really not. It's not math. In fact, it's more or less kind of a humanities. It just uses math as a tool. So stats is really just finding meaning and significance in data and putting that information, whatever we found in our data, putting it to use and using it in real life. Rather than just saying some complicated models or findings or whatever. Stats is used in nearly every scientific field. Chemistry, biology, psychology, sociology, engineering, just all of that. City planning, all that stuff. Stats is used all the time. Stats is used all the time. It's also misused fairly frequently. And it's my goal to sort of separate the two and help you figure out when things are being used properly and when they're not. So, stats is really a tool that we use to find this meaning and significance in data. It's a field. It's a field of mathematics technically, but it really is just a bunch of tools that we use to figure out sort of conclusions from the data that we've collected. But it doesn't tell us everything. It can tell us things on a mathematical side, but it takes some work on our end to actually find the meaning in that and the actual interpretation. So let me tell you a story. I won't do this all the time, but this one is especially interesting, I think, that sort of started statistics as a whole, more or less. So, The Lady Tasting Tea. This is actually a great book, too. I highly recommend that you read it at some point. Super interesting about the history of statistics. But this fella right here, this is Ronald Fisher. And then this lady here we'll get to in a second. But way back in the day, early 1900s, very early 1900s, this fella was sitting with his colleagues and fellow professors at Cambridge. And they were just sitting around having a good time. And this lady claimed that she could tell whether or not milk was added before or after the tea was brewed. Okay, interesting claim, right? Doesn't really do anything for us in the real world, but it is something that is rather curious. So Ronald Fisher and his friends, his pals, came up with a test. And that test looked something like this. They got 8 cups of tea and they randomly put milk in after or before pouring the tea. And then they lined them all up like so, and then asked the lady who was tasting the tea to say whether or not she thought that the milk was added before or after the tea. Okay. So, very interesting. Like, very curious, right? Who really cares? But it is, kind of curious. So, what they wanted to figure out was how can they actually tell whether or not she actually knows the tea was added before or after, or she's just guessing, right? Because you have a 50% chance of being right, right? Let's say that cup number 1 here had milk first and then tea. Cup number 2, same deal. And then cup number 3 was the opposite. The tea was first and then the milk was poured in. In reality, you have about a 50% chance. And to keep going on and on and on and get it right every single time, turns out it's like less than a 1% chance of being spot on every single time. Also, there is some room where she does get it all right, but maybe misses one, right? There's some variability there. So many different ways that you can go about kind of thinking about it. Well, as time went on, she drank all the cups of tea or tasted all the tea, and she got every single one right. Very interesting. Was she guessing, or does she actually know? Who knows, right? And so then it was Ronald Fisher's job here to really figure out, well, what the heck? How can we test whether or not she actually knows, or it was just due to random chance, right? It was that less than 1% chance of being totally right. Maybe we lived in the world at that time when that was possible. If you were to maybe do it again, would it be the same? Would she be able to get all 8 again? If we had more cups of tea, let's say we had 100 cups of tea, do you think she'd be able to get every single one right? Well, we don't know, right? And that was sort of where it all started for Ronald Fisher, sort of one of the founding fathers of modern day statistics. And it was just, you can read the book, but he went on to figure out a bunch, and he went to go on and develop and figure out a bunch of different statistical tools. So let's move on. This brings us to this idea of descriptive statistics and inferential statistics. So the descriptive statistics is fairly simple, right? In this case, in the lady tasting the tea, the descriptive statistic would be she got 100% correct, right? She got 100% of the cups of tea she guessed correctly, right? Or she knew correctly, okay? That's just what happened. That's just what the data, right? That's what the data looks like. And that's it, right? You have a 50% chance of being right. You have a 50% chance of being wrong. And that's about it, right? But the inferential statistics is what we use to make a conclusion about what we saw. In this case, right, we saw that she got every single one right. Maybe we can conclude that she can accurately determine whether milk was added before or after the tea, right? Or maybe we can infer something else, right? Something else about the process. Totally up in the air, right? So the idea here is that descriptive statistics, sort of the basics, right? And fairly obvious, but the inferential statistics is what we have to use, quite a bit of critical thinking and kind of logic to make our own conclusions and to back up our results. Okay, so then we move on. Ronald Fisher moves on and sort of develops this idea of taking a small sample from a population and kind of figuring out, based on that sample, what the population maybe looks like. Okay, interesting. Moving away from the tea example, moving into something different now. This is sort of the next big idea in statistics. So let's say that you've got a barrel full of saltwater taffy. Okay, all in here. And it's got 10,000 pieces of various colors, pink and blue and yellow and green and whatever else. And you want to figure out how many red pieces there are, how many blue and yellow and green. You want to figure out how many of each color is in this barrel. Now, what you could do is pour out the barrel and just sift through 10,000 pieces of saltwater taffy and take a week to count all of those things. Or you can just grab a handful of saltwater taffy and maybe kind of estimate or guess as to what you think the barrel looks like. Okay, so in this case, our sample is here. And I don't like that green. Here we go. So this is our sample, right? Just that handful of saltwater taffy. And here, sort of this thing here, this is our population. Okay. And so we take a sample, do a little bit of math on it to infer what we think the population looks like. All of the taffy in the barrel, right? Okay. So what we do is we take our sample, we do a little bit of math, right? We use our tools that we will learn here in the future. And then we estimate. Big deal here is that we are estimating what the population looks like. Okay. So the big thing here is that this is our population, and then this is our sample. Anything that we find when we use our tools here is only applicable to this barrel. It's not applicable to all of the barrels that came out of the taffy factory, and it's not applicable to all of the taffy barrels in the world. We're only able to estimate. We're only able to infer about this barrel that we have. This is our population. And that goes for pretty much everything in statistics. So another example would be like the census in the US, right, is a survey that gets sent out to people, ideally to everyone, right? And you're trying to estimate sort of the demographics of the US population, okay? But what that survey does is only tells us, it only infers what the US population looks like. We cannot take those findings and say, based on the US, right, we can't say that it's the same for Russia or China or Canada or Mexico. We can only say what we know about our sample since it came from the US population, okay? So let me actually go back here to erase this so I can be a little bit more kind of detailed here. So this would be our population over here. Population. And then this, the barrel, you can think of, is the sample space. And depending on, who you're taking statistics from in the future, this idea of the sample space is either harped on all the time or never. And I'm going to be the person that doesn't harp on it. But typically, that idea of the sample space is represented with this symbol here, this omega symbol, sample space. Okay, so we've got the population, we have our sample space where the population, sort of resides, and then our sample, right? And then that's that, right? We go through our process, figuring out, kind of inferring what the population looks like, right? Just in this case, it's the barrel, not all of the barrels, and then we're able to kind of guesstimate, sort of estimate here with that symbol, what the population looks like based on our sample. Very cool, right? Very cool. So, short-ish video, but here's what it's really all about to me and to a lot of people in our department, I think. And this is kind of becoming the norm too, which is so great, especially since we have computers and calculators to do a lot of the work for us. But statistics is like 60% communication and critical thinking. And then 25% is visualizing the data, so graphs and figures and whatever else. And then like a very small percentage, still, decently large, but not a huge, it's not shadowing everything else, is the math, right? We can do the math, but that's not it. We're missing a ton of the whole story, right? Because that's what statistics is all about, is really telling a story, right? So last example, sort of, in this video at least, is let's say that if you have a sibling or a brother or sister, or whatever, or a friend or a pal or a neighbor, doesn't matter. But they come over to you and say, your brother or sister, they come over to you and say, I have used statistics to find out that our mom loves me more. Okay, how did you do that? Well, your brother or sister say that, well, I get more ice cream every night than you do. Just a little bit, but it's consistent enough to where, okay, I think that mom loves me more. Okay, so, sure, whatever. Whatever. But what you have on your side is, okay, maybe that they get more ice cream, but I get more sprinkles. What does that mean? Well, it probably means that your initial claim, or their initial claim, that your mom loves them more is probably not true. You just have evidence that you get more ice cream, and that you specifically get more sprinkles. Okay? Maybe you could visualize that data somehow based on like time or whatever, an ice cream amount or sprinkle amount. But 60% of that, you're missing out that big critical thinking. It probably doesn't mean that your mom loves you or your sibling more. You're just saying that, or you're just sort of finding that you get more sprinkles and they get more ice cream. And that's that, right? No need to really dig into it anymore. So that's what statistics is sort of all about. It can get complicated as you get further into the field. But this class, the goal, I think, for this class is to get you familiar with tools in statistics, how statistics is used in real life, and to get you sort of to be a little bit skeptic of what you see in the world. Not totally ignoring everything and saying that it's false, but just giving it some critical thinking. So that's the preface, that's the prelude, and I will see you here in just a second.